Today we are continuing day 2 of solving by factoring. So we did this yesterday. Remember, when we're doing this, we're finding the solutions, or they're also called the roots, the zeros. They're also the x-intercepts of the graph. So we are looking for, these all mean the same thing. So let's look at the first one. 2x squared minus 14x equals 0. So the initial condition is met. It needs to be equal to 0, and it is. So the first thing I'm going to start looking for is a GCF on the left side, 2x squared and 14x. So they have a GCF of 2x, 2 goes into 2 and 14, x goes into x squared and x. So if I factor a 2x out, then I'm left with x minus 7. The zero product property says that if I have two factors multiplied together and their product is 0, then either the first factor is 0 or the second factor is 0. So I'm looking for the x value that will make the first factor equal to 0, and I'm looking for the x value that will make the second factor equal to 0. You can probably look at them and see, well, if I multiply 2 times 0, that would be 0, so 0. And if I subtract 7 from 7, then that would be 0, so 7. And that's correct. We're looking for 0 and 7. And we can see that simply by setting each of these factors equal to 0 and solving them. 2x equals 0, x minus 7 equals 0. Divide by 2. Our first solution is 0, just like we thought it would be. Add 7. My second solution is 7, just like I said it would be. And we can see that 0 would make the first factor 0, and 7 would make the second factor 0, because 7 minus 7 is 0. Alright, so 18x squared equals 3x plus 1. The initial condition is not met yet. Everything needs to be on the left side. So I need to move the 3x to the left side. I also need to move the 1 to the left side. So I'm going to have 18x squared minus 3x minus 1 equals 0. Alright, now this is the one I want to factor. Whoops, 18x squared minus 3x minus 1. The GCF, of course, is just 1, so nothing's happening there. So I'm going to use my x to factor this, and the a value is 18, so I'm not going to be able to skip the grouping part. I am going to have to do the grouping on this problem. So up top is a times c, so 18 times negative 1, so negative 18. And the bottom is b, negative 3. So I'm looking for numbers whose product is negative 18 and whose sum is negative 3. So I'm looking for negative 6, positive 3. These two add to negative 3, they multiply to negative 18. So, since a is 18, I have to do this the long way. So I'm going to use negative 6 and positive 3 to split up the middle term. So I got 18x squared minus 6x plus 3x minus 1. And I'm going to group the first two together. I'm going to group the second two together. And I'm going to factor the GCF out of each group. GCF of the first group is 6x. GCF of the second group is 1. So I'm going to factor 6x out of the first group. I'm going to factor 1 out of the second group. If I factor 6x out of the first group, I have 3x minus 1. If I factor 1 out of the second group, I have 3x minus 1. Which means that this factors into 3x minus 1 as the first factor and 6x plus 1 as the second factor. So the factored form, let me go back to my problem. So the factored form here becomes 3x minus 1 and 6x plus 1, and those multiply to give me 0. So, zero product property says that either of these could be 0. So I want to find what value of x will make the first factor 0, and what value of x will make the second factor 0. So I'm going to set the first factor equal to 0 to find x. I'm going to set the second factor equal to 0 to find x. So I'm going to have two solutions. Let's solve each of these. Add 1. 3x equals 1. Divide by 3. X equals 1 over 3 is one of my solutions. For the other solution, subtract 1. 6x equals negative 1. Divide by 6. X equals negative 1 over 6 is my other solution. So these are my two solutions. 1/3 is the x value that makes the first factor 0, and negative 1/6 is the x value that makes the second factor equal to 0. So those are my two solutions for that problem. That was number 2. Now this is something a little bit different. It says, it says write a quadratic equation in standard form with the given roots or the given solutions, and we want our a value to be equal to 1. So we're looking for an equation in standard form, ax squared, well actually a is 1, so it's going to look more like x squared plus bx plus c equals 0. So what it says is that our solutions, or our roots, are 3 and 2, negative 2. So 3 and negative 2. So 3 implies that one of the factors would be x minus 3. Because if x minus 3 was one of the factors, then 3 would make this factor 0. Negative 2 implies that another factor would be x plus 2. Because if negative 2 were plugged in for x, this factor would be 0. So the factored form would be x minus 3 times x plus 2. But I want it in standard form. So I would have to distribute here to figure out what it would be in standard form. So if I distribute, x times x is x squared, x times 2 is 2x, negative 3 times x is negative 3x, and negative 3 times 2 is negative 6. So this, almost in standard form, I still need to combine like terms, the 2x and the negative 3x. So you get x squared minus x, or minus 1x, minus 6 equals 0. This is the equation in standard form that has the solutions 3 and negative 2. I know that it has the solutions 3 and negative 2 because its factored form has the solutions 3 and negative 2. So the standard form must also have the solutions 3 and negative 2. Alright, so number 2. The solutions need to be 0 and negative 1. Well, 0 implies that the factor is just x, the first factor. Because if x is the first factor, then the solution would just be 0 for that factor. Negative 1 implies that the factor is x plus 1. Because negative 1 would make this factor equal to 0. So my equation is x times x plus 1 equals 0. This is in factored form. I want it in standard form, so I need to distribute. X times x is x squared. X times 1 is x equals 0. And this is my equation in standard form that has the solutions 0 and negative 1. Alright, the homework. Wait a minute. Check Canvas for the homework.